All right, so now we're going to look at the short answers for the quiz that we did last week in class. The first question, question 10, was to clearly describe the difference between a longitudinal wave and a transverse wave. So there's 2 marks for this question. The first mark was awarded for some notion of discussing that in a longitudinal wave, that the particles move in the same direction as the actual motion of the wave. So this is just to show, you can describe with words. I'm going to quickly use a diagram just because we don't want to wait for me to describe all this. But if we have a longitudinal wave, the motion of the particles and the actual motion of the wave, the propagation of energy of the wave, are in the same direction. With a transverse wave, the motion of the wave is still, in this case, horizontal, but the actual motion of the particles is not parallel to this, it's perpendicular. So that was one point to mention that or draw it. Another thing is to mention that a transverse wave consists of crests and troughs, and that a longitudinal wave consists of areas of compression and rarefaction. All right, question 2 was to reflect these waves given the boundaries, whether they were fixed or free. So first thing you needed to notice is that this is a fixed boundary, and a hollow circle represents a free boundary. So when an object encounters a fixed boundary, it reflects out of phase. So to reflect out of phase, it has to flip horizontally and vertically. So that's going to give us a diagram that looks like this. If it's going to reflect at a fixed boundary, it reflects in phase, so it just flips horizontally. And there's your 2 marks there, 1 each. Okay, this last question here. On a standing wave below, the length of the string is 2.5 meters, and the velocity of the wave is 4.3 meters per second. Find the wavelength and the frequency of the wave. So, really, for part A of this, to find the wavelength, all we need is the length. So the length here is 2.5, and what we need to remember is that we define n, the harmonic of a standing wave, by how many antinodes there are. Antinodes being these spots here. Areas that go from maximum displacement above the equilibrium line to the maximum displacement below the equilibrium line. So that would be these points here. We have 1, 2, 3, 4, 5 of them. So this is indeed the 5th harmonic. We need to count by the antinodes. So knowing that, and that our equation for a standing wave is that the wavelength is equal to 2L over n, we can rearrange to solve for wavelength. Sorry, we don't need to solve, sorry. It's already the way it's supposed to be. Wavelength is equal to 2 times, in this case, 2.5 meters divided by n, which is 5. And 2 times 2.5 is 5. 5 divided by 5, wavelength is 1.0 meters. It's kind of convenient. So, keeping in mind, there's 2 sig figs in this question in both spots. So we want to keep 2 sig figs in the answer, 1.0 meters. So that was the first part. This is the wavelength. Now, the frequency is solved just with the wave equation. So velocity is equal to f lambda. Rearranging for f, we get frequency is velocity over wavelength. Putting in the numbers we have a velocity of 4.3 meters per second and a wavelength of 1.0 meters. This gives us a frequency of 4.3 hertz. If you made a mistake here and you calculated the wrong number and you used that incorrect answer to find frequency, you should still get the marks for frequency if you used the right equation and did the right calculations given the wrong number. So there was 1 mark here for the wavelength and 1 mark here for the frequency.